Alright, so have you ever considered why a low and high power appliances have different thickness of the wire? So why do high power electrical appliances have thick wire? So consider two appliances, right? So the very first electrical appliance is a kettle that has 60 watts and 240 volts. So normally in physics question, they will say, this kettle normal operation is at 60 watts 240 volts. So you'll be given first of all the power. Then after that, second of all is your potential difference, or maybe I just call it V lah, voltage. Okay, so you will not be given the current value. Okay, so how do we calculate the current value for the first low power kettle? So of course I must use the idea of P equal to VI. So 60 divided by 240, you will get roughly 0.25 ampere. Yeah, so this kettle, right, is drawing a current of 0.25 ampere when it's connected to a 240 volt supply. So 240 volts is roughly the so-called the voltage of your Singapore socket. So 0.25 ampere, that is for the first low power kettle. Okay, the next will be high power kettle, which is roughly 3000 watts 240 volts. So in order to operate normally, right, I must have a potential difference of 240 volts across the high power kettle. So first thing, current, right, P equal to V over I. So 3000 divided by 240. So it's roughly 12.5 ampere. So you can see that these two kettles, right, is drawing a different amount of your current. Okay, so first is quite low, 0.25 ampere only. The other is 12.5 ampere. Okay, the next thing that you will notice that, for the high power kettle, the wire is rather thick. For the low power is rather thin, right? Okay, so why is that so? Because thick wire can actually reduce the resistance. Okay, so resistance is reduced. Why is it the resistance is low? Because remember our R equal to row length over area, right? So as area increase, the resistance will decrease. Okay, provided that both the cases the length is the same, and of course it's made of the same material, which is the resistivity. So if your area is thick, your resistance will be low. So high current that flows through the so-called thick wire here will not cause so much heating effect, because heating effect will cause overheating, and of course eventually it will cause the temperature to get high enough and cause a fire. Okay, so for thin wire for the low power kettle, right, the thin wire has a high resistance because of R equal to row length over area. So thin wire will cause high resistance, but it is okay because the current that's drawn is only 0.25 ampere. So your wire can have a high resistance, and the heating effect will not be so huge. Okay, but for those high power kettle or electrical appliances, you need to have a very thick wire. So of course thick wire is more expensive because you need more metal, a lot of insulation, and of course more material to make the thick wire. So that is the cost of having a thick wire.